Good afternoon. I'm Dr. Ilkka Paananen from the University of Jyväskylä, and this talk is about using spectral imaging in provenance research of the fine art. Has anyone bought fine art recently without proper provenance research? Hopefully not, because it is estimated that 40% of the art on markets are forgeries. Trusting to connoisseurs can help, but there is risk of bias. Luckily, science can help. Different imaging modalities can be used to see through paintings, for example X-ray, or spectroscopic techniques can be used to identify materials. Hyperspectral imaging now combines these both techniques so that we can actually see image and see something information about materials also. Thus we can actually identify pigments, find anomalies, or find hidden features from the image. And this study is basically about this, finding hidden features. And for the finding process we are actually using 3 different hyperspectral unmixing models to detect something beneath paint layers, and we are using hyperspectral imager which is ranged from 1 to 1.7 microns, and we are using linear mixture model, bilinear model, and then nonlinear approximation of single scattering albedo from the reflectance, which is now nonlinear case here. And we are studying 2 paintings, which first one is Claude Monet's Haystack in the Evening Sun, and the other one is claimed to be Frans Hal's portrait. And this Monet painting is actually very similar to the famous series of haystack paintings. It's just smaller and without signature, and Hall's painting has something disturbing with the paints or pigments in this portrait, and we will see soon why. Here we then in processing use total variation based denoising, then vertex component analysis to extract end members, and then we calculate inversions for each models and then interpret results. And here we see actually now the most interesting results, which try to find actually this signature of Monet, which is between paint layers, and in this Hall's case there is actually old wooden panel where is flowers in the painting beneath, and we can see that linear and this half-cut nonlinear model can detect these changes quite well, when bilinear model actually fails. And basically, if we want to gain optimal distinguishing between visible painting and hidden features, we should have case separate models. In Monet's case, the paint is between, the signature is between the similar paint, but in Hall's case there are lots of different paints layers, and then there is this floral painting from 16th century, and then pigments from 1930s above. As a concluding remarks, we could say that hyperspectral imaging can reveal details from the painting which are invisible for eye or undetectable with other results. For example, X-ray couldn't see this floral painting or Monet's signature. And it seems that linear mixture model is computationally enough efficient to distinguish these hidden features. Thank you.